Here we have been asked to find the total number of the structural isomers of C4H11N. The first approach in these type of the questions should be to find the degree of unsaturation DOU. The degree of unsaturation in organic compounds which are going to have nitrogen. The method to find the DOU is as follows. You are supposed to remove the nitrogen from the molecule, and for one nitrogen that you remove, you are supposed to add one carbon and one hydrogen. So here C4H11N, so we remove one nitrogen and we add one carbon and one hydrogen. So what we get is C5H12. So here what we observe is there is absolutely no presence of rings or a carbon-carbon double bonds, because this is an alkane which looks like this and pentane. So the degree of unsaturation for the given formula C4H11N is going to be 0. So in the structures that we are going to obtain which have this formula C4H1110, there will be no carbon-carbon double bonds and no rings. So now we have to think that what are the structures that we can obtain out of this formula which has been given to us. And we have to remember that all the structures have to be aliphatic in nature. Rings are not allowed in this case. And then we also simultaneously have to think that what are the groups that are going to have the nitrogen atom within them. So there are three possible groups. One is a cyanide, one is an isocyanide, and one possibility is going to be amine. So there are these options, but what we understand is that the DOU is equal to 0. Hence pi bonds are not allowed. The compound has to be completely saturated. So amine group is the only possibility. Cyanide is not allowed. Isocyanide is also not allowed. So then we have to think that what are the amines that we are able to make with this formula here. And as we know that there are three kinds of amines: 1 degree amine, 2 degree amine, and 3 degree amine. In 1 degree amine, what we observe that the nitrogen atom is linked to one carbon atom and two hydrogen atoms. Then in 2 degree amine, what we observe is that the nitrogen atom is basically linked to two carbon atoms and one hydrogen atom, and a 3 degree amine is one in which the nitrogen atom is linked to all the three carbon atoms and there are no hydrogen atoms which are linked to the nitrogen atom. So now we have to make a list of all the possible structures, all possible 1 degree amines, all possible 2 degree amines, and all possible 3 degree amines. So I have already done this work here. So what we are able to observe is that for 1 degree amine, we can have this structure in which the nitrogen atom is attached to the carbon atom at the end of the chain. Then we can have one more structure in which the nitrogen atom is linked to the carbon atom in the middle of the chain. Now understand that I have put this nitrogen at this carbon atom. I could even have put it here, but it would give me the same structure back again. Here in this case, I have put the nitrogen atom on this carbon. I could have put it here, but it would give me the same structure. Now here what we are able to observe is that in this structure, the nitrogen atom has been linked to this carbon atom, and here in this structure, the nitrogen atom has been attached to this carbon atom. Now, as I said, this carbon atom, and this carbon atom are basically similar. So, if I were to attach the nitrogen atom to any one out of these three carbon atoms, it would give me the same structure back again. So, for 1 degree amines, we have identified four possible structures. For 2 degree amines, we have identified these three possible structures. What we have done is we have attached the carbon atoms to the nitrogen atoms such that one atom is linked to the nitrogen, and the other group of carbon atoms linked to the nitrogen atom is going to have three atoms. The second possibility of 2 degree amine is that both the groups of the carbon atoms linked to the nitrogen atom are going to have two carbon atoms each. The third possibility of 2 degree amines is that one group is going to contain only one carbon atom, but the second group is going to contain three carbon atoms. But this is linked in a different manner. If you look at this structure and if you look at this structure, you will understand the difference. That here the nitrogen atom is attached to the carbon atom located in the middle of the chain, and here in this structure the nitrogen atom is linked end carbon located in the chain. So for 2 degree amines, we are having these three possible solutions. And for 3 degree amine, in which the nitrogen atom, it will be linked to only carbon atoms, we have only one possible structure. So here what you are able to see is that there are two groups attached to the nitrogen atom in which only one carbon atom is present, and there is one group attached to the nitrogen atom in which two carbon atoms are present. So after this analysis, we can say that 8 possible structures can be obtained, and hence we can say that the appropriate answer to this question is going to be option B, that is 8 number of the structural isomers from the formula C4H11N can be obtained.